Hi, welcome back. This is part 2 of the review video for chapter 10, and now we're going to talk through the problems on the back side of the review sheet. So on these, the directions say to multiply. Number 21, the square root of 3 times the square root of 7 would be equal to the square root of 3 times 7, the square root of 21. Number 22, the square root of 2 times, in parentheses, 8 minus the square root of 2, we can distribute. So the square root of 2 times 8 minus the square root of 2 times the square root of 2. And then when we have the square root of 2 times 8, we have to just write that as those two things multiplied together. But I'm going to put the 8 in front to make it obvious that that's not under the square root sign. The 8 is just sitting there being an 8. It's not part of the radical. So we have the number 8 times the number square root of 2. And we can't do any combining there because the 8 is not under a square root sign, but the 2 is. But then when we take the square root of 2 times this other square root of 2 and multiply those together, we get just 2. And you can either think that's because this is the square root of 2 times 2, the square root of 4, which is just 2. Or you can think the square root of 2 times itself, the square root of 2 squared, is 2. And then these can't be combined, so we're all done. 8 times the square root of 2 minus 2 for the final answer. Number 23. Here we are multiplying together 5 minus the square root of 23 times 5 plus the square root of 23. Now, if you use the FOIL method to multiply that out, first we get 5 times 5, which is 25. Outside, we get a 5 times a plus square root of 23. Inside, we get a minus square root of 23 times 5. And last, we get a minus times a plus is minus square root of 23 times itself, or square root of 23 squared. And let's see what happens here. We got our 25. We got these two terms in the middle that are the same as each other, except one's a plus and one's a minus. So they add up to 0. And then it's minus the square root squared would just be 23. And then finally, 25 plus 0 minus 23 is 2. So we end up with just 2 for the answer. For the next problems, the directions say rationalize each denominator, then simplify if possible. So that means in our final answer, we don't want a denominator that has a radical in it. The square root of 7 over the square root of 11. We multiply by another square root of 11 on the bottom, and then the same thing on the top, so that on top we get square root of 7 times square root of 11 is square root of 77. On the bottom, we get the square root of 11 squared, which is just 11. So we have rationalized the denominator. The denominator is no longer irrational, it's just 11. Mission accomplished. Number 25, to rationalize this denominator, square root of 2, we need to multiply it by another square root of 2. And we have to multiply by the same thing on top and on the bottom. So on top we have 8 times the square root of 2. On the bottom we have the square root of 2 times itself. Square root of 2 squared would just be 2. And then 8 times the square root of 2 divided by 2 simplifies to 4 times the square root of 2. The 8 divided by 2 is 4, and then that's times the square root of 2. 18 over the square root of 10 plus 1. So remember the trick to rationalizing a denominator like this, where there's more than one term. We have to multiply by what's almost the same, but with a different sign in the middle. In this case, since this has a plus, we need ours to have a minus. We're taking the square root of 10 plus 1, and we're multiplying it by the square root of 10 minus 1. Because when we multiply that out, we get the square root of 10 squared, which is just 10. The outside and the inside cancel out. One's a minus square root of 10 and the other's plus square root of 10. And then last we get the plus 1 times the minus 1 is minus 1. So that ends up just being square root of 10 squared is 10, minus 1 is 9. That way we end up with just a denominator that's just a simple whole number. Meanwhile, on top, we're taking this 18 times this square root of 10 minus 1. If you multiply it through, it would be 18 times the square root of 10 minus 18 times 1. And then we can divide what's on top by the 9 that we have on the bottom, and the answer could be written in factored form as 2 times the square root of 10 minus 1, or in the multiplied out version, 2 times the square root of 10 minus 2. Now we're solving some equations that involve radicals. Remember our process. Get the radical by itself on one side, then square both sides because squaring undoes the square root, then finish solving to get what x is equal to, and then check to make sure your answer really does work. And if anywhere along the way you get a square root equal to a negative number, you could stop right there and say there's no solution because square roots are never negative. When we write the square root of something with a radical sign, we mean the positive, not the negative square root. Okay, so square root of 4x minus 7 equals 3. The square root is already by itself on one side, so square both sides. Over on the left, the squaring just undoes the square root and leaves us with 4x minus 7. And over on the right side, the 3 squared is 9. So now we have the equation 4x minus 7 equals 9 to solve. Add 7 to both sides and we get 4x equals 16. Divide both sides by 4, we get x equals 4. And that does work because if you go back to where we started and put 4 in for x, 4 times 4 is 16. 16 minus 7 is 9. The square root of 9 is 3. And the equation is true. Number 28. Now here, before we get rid of the radical sign, we need it to be by itself on one side. We need it isolated without anything else that isn't under the radical sign. So we start by getting rid of the minus 5 by adding plus 5 to both sides. Then we have the square root of x plus 2 all by itself equals 8. Now we square both sides. That undoes the square root, and x plus 2 equals, and then 8 squared becomes 64. Then subtract 2 on both sides and we get x equals 62. And that is our final answer. If x is 62, 62 plus 2 is 64. Square root of 64 is 8. 8 minus 5 is 3. With number 29, again, isolate the radical. So get rid of the plus 4 part that's not under the square root sign by subtracting 4 on both sides. And then I notice that this says the square root of 2x equals negative 3, which can't happen. You can't have a square root equal to a negative. So right there we can say no solution. Now, one thing to be careful of, watch out for what is or is not under the radical sign. It makes a big difference whether this is 2x plus 4 all under the square root sign, or whether it's just the 2x under the square root sign and then a plus 4 outside. Make sure you pay attention to what is and is not included underneath that square root sign. Okay, number 30 is one of those right triangle Pythagorean theorem problems. It says in a right triangle with legs 6 centimeters and 10 centimeters, so I've gone ahead and drawn that. How long is the hypotenuse rounded to one place after the decimal point? So the Pythagorean theorem says that a squared plus b squared equals c squared. Here we have numbers for a and b, the two legs, and the c, the hypotenuse, is what we're trying to find. So if we plug in 6 and 10, this says 6 squared plus 10 squared equals c squared. 6 squared would be 36, and 10 squared would be 100, and when you add those together, that's 136. So c squared equals 136, and that means c, to undo the squaring, we got a square root. C would be the square root of 136. If you ask your calculator what that is, it'll show up as 11.66 something something something, and if you round that to the nearest tenth, to one place after the decimal point, it's 11.7. So the answer, 11.7 centimeters. And finally, we have some operations involving complex numbers. So remember, whenever you see the square root of a negative number, that's when I gets involved. It would be the square root of the positive number times I. So the square root of negative 81 would be the square root of positive 81, which is 9, but then times I. And of course, 5 plus that would be 5 plus 9i. So that's in that standard form of one number plus another number times I. The square root of negative 19 would be the square root of positive 19 times I. Here I put the I in front to make it obvious that the I is not under the radical sign, but if you wrote it at the end and made sure it was not under the radical sign, that would be correct also. To add complex numbers, it's really like combining like terms. 1 plus 3 is 4. The negative I plus the negative 4i is negative 5i, so the answer is 4 minus 5i. To subtract, it's like subtracting polynomials and combining like terms. The 7 minus the 3 would be 4. The minus 2i minus the negative 8i, and remember when you have minus a negative, that's the same as plus a positive. So the minus 2i plus 8i gives you a positive 6i, and so the answer is 4 plus 6i. Make sure you pay attention to what the operation actually is. In number 33, we were adding. In number 34, we were subtracting. In number 35 and number 36, we are going to be multiplying. So 35 to multiply I times 4 minus I. We distribute, use the distributive property. I times 4 would be 4i. Minus I times I would be I squared. That's what I squared means. It means I times I. But remember, whenever you see I squared, that's just negative 1. I stands for the square root of negative 1, so I squared would be the square root squared, which would just be negative 1. So we're looking at 4i minus negative 1, and minus a negative would be plus a positive, and if we put the I part last and the real part first, it looks like 1 plus 4i. And number 36, using the FOIL method here, 2 times 7 is 14, 2 times 2i is 4i, I times 7 is 7i, and last, I times 2i is 2i squared. But whenever you see I squared, just go ahead and turn it into negative 1. Combine the I terms, the 4i and the 7i together make 11i. So we're looking at 14 plus 11i plus 2 times negative 1, which would be negative 2. And the 14 and the negative 2 together make 12. So we have 12 plus 11i for our final answer. Now, I didn't put any problems on here involving division of complex numbers. I kind of treated that as a bonus topic. If it's on the test at all, it would be as a bonus problem, but it might be a bonus problem. So if that happens, you don't have to do it, but if you think you know how to do it, because I did talk a little bit about it in the video for section 10.7, you could try doing it as a bonus problem if it's on there. But don't worry about it if there's still other things you need to study. So there is this review sheet with and without answers posted on Canvas. There's a sample test and answers to the sample test. If you try working through the sample test and get them all right, you're in great shape for the test itself. Hope this helped. Good luck on the test.